Alright, this definitely was a weird one. This is kind of like out of my comfort zone. But I think I figured it out. So let's see. It says at a certain hospital. Actually, let me change something up here so I can write. Use green this time. Okay. At a certain hospital, 89 children were born in June. Alright, so you've got the month of June. First of all, June has 30 days. That's one thing that you need to know about this. Actually, I think it even works if you thought it was 31. I don't think it works with 28 days if it was February, but I think for all the days, or for all the months, I think it works. But anyway, June has 30 days. We'll use 30 days. So I always remember it, 30 days, half September, April, June, and November. All right, it's just a little rhyme. All the rest of 31 except for February, whatever. Then the rhyme kind of goes away. Anyway, June has 30 days. If more children were born on the 15th of June, so that's June 15th, than any other day in June, all right, so you got June 15th, and so more children were born on that day than any of the other days. That means that's the most number of children were born on one particular day of the month. What's the least number of children that could have been born on the 15th of June? Right? So we say, well, more children, well, let's say, oh, okay, all 89 children were born on June 15th. Well, that wouldn't work because that's not the smallest number of children that could have been born on that day. That's actually the most number of children that could be born. So you figure the other ones would all have zeros, so that's not the least number of children that could be born on that day. Well, I don't know if I'm going to do a great job of explaining this, but just bear with me and we'll see how it goes. So June has 30 days. What I did, at first I actually wrote out all 30 days, 1 through 30, but you don't really need to. And the fact that this is the 15th of June really doesn't make any difference at all. It could have been any number. It could have been the 1st of June. It could have been the 30th of June. It doesn't make any difference that it's actually the 15th of June. So what I did was this. I said, okay, on one day, actually, I didn't do that yet. Forget that. Told you I was going to have a hard time explaining this. I did take some notes on this, but let's figure this out. What if I don't know? Let's just say randomly 2 babies were born on every day. So that means if there's 30 days and 2 babies were born, that's 60 that's 60 babies that were born. Okay. So 60 babies. Well, that's a lot less than 89. But if I take 60 away from 89, so 89 minus 60, that's 29 babies that are left over. I guess we'll call it leftover, all right? So let's say every single day. Now that would mean that on that 15th of June or that one particular day, there wouldn't be any more born that day than any other day. So we're saying that every day 2 babies were born, but we still have 29 babies left over. So let's do this. Let's spread those babies out through the other 30 days. So that means, let me think of how I'm going to say this. So if I spread these out, that means that there's going to be one day where only 2 babies were born. If I take these 29 and I give them to the other days, so you've got 30 days, and we're saying that 2 were born each day, or on each day, all right? So if I spread those other 29 that are left over throughout those 30 days, one day is still only going to have 2 babies. So one day is only going to have 2 babies. But that means that what? The other 29 days are going to have 3 babies. Does that make sense? I think it does. Okay, so there's your 89 right there. So so what is that? 29 times 3 is 87, plus the 2 on that one day. There's your 89 babies. But the problem is, on that 15th of June, or that one particular day, there's no more babies born on just one day. Do you see that? See, I got 29 days where I got 3 babies born, one day where there's only 2 babies born, but on one day of that month, there's got to be more babies born on that one day than any other day. So what I'm going to do is this. Let's take that one day, the 15th, and take one of, let's see, we'll take one of these babies, again, my explanation is pretty rough here. So yeah, let's take one of these babies and give it to day 15. So you're going to have 1 day. Let's do this again. So we're going to have 1 day. If I take one of the babies born on any of these 29 days, let's say on the 1st, okay, and then we give it to the 15th. So we're going to have 4 babies born on the, let's say, the 15th. That's the 15th of June. Okay, so we'll have 1 day. We're going to have 4 babies. But what did we just do right here? Every other day's got 3 babies. I took 1 away from one of these days and I put it here. So we've got 1 day where you have 4 babies. That means 28 days has, did I do that right? 28 days has 3 babies. I don't think I'm doing this right. Hang on, let me double check. Okay, I think I have this figured out. This is not 28 days right here. This should be 27 days. And this should be 27 days because, and then you're going to have the 1 day. So the 1 day, the 15th, that's the one with the most number of days, is going to have your 4 babies. Then you're going to have 27 days with 3 babies, and then your then you're going to have 27, 28, 29. Actually, you're going to have 2 days. You're going to have 2 days with 2 babies. I didn't explain this very well at all because I'm not completely positive about this myself. But I think I gave you something to work with here. So let's see what we have. We got 27, 28, 29, 30. There's 30 days right here. And that's 21. That's, let me make sure. Yeah, we're right. This is 81, so this is 81 babies right here. This is that 1 day, the 15th, where it has more than any other day, right, which is 4 babies. And this is 2 days, right, with 2 babies, and that would be 4 babies right there. And that would give you, that's 8 and 1, 9, so that's 89, total of 89 babies. So there you go. 1 day had 4 babies. So that's really what you're looking for. You're looking for the 4. Which day, what is the least number of children that can be born on the 15th? Okay, that's the most number of babies that were born on any of the days. 2 of the days had 2 babies, 27 days had 3 babies, and that 1 day, whatever it is, we call it the 15th, had 4 babies. That's the most born on any of the days, but it's the smallest number that could have been born on that one particular day. Sorry about the explanation. This really wasn't my my expertise whatsoever, so I hope I helped a little bit on this. Alright, let's look at this problem. It's not really a triangle. What they start off is they say that points, I mean it is a triangle, but here's how they started off. They start off with points Q, R, and S lie on line L. Okay, this bottom line, we'll call it line L, in that order. So Q has to go first, then R, then S. R doesn't have to be exactly right here. R could be anywhere in between Q and S, okay? And that's what we're going to do. We're going to move it around a little bit. It could come real close to here. It could be right in the middle. It could be way over here. It could be anywhere between Q and S. But it also says that PQ and PS are equal to each other. So PQ, this segment, and this segment right here are both equal to each other. Which of the following must be true? So what we want to do, we've got A, B, C, D, and E. I want to find out which one of these inequalities must be true. So let's just take a look. I've got PQ and PR. Let's find PR. Well, PR would be from here to here. Now remember, R could be anywhere. R could be anywhere along this bottom line right here. What I'm going to do is, I'll tell you what, just remember that these 2 line segments are equal to each other. And I drew them so that they were. In fact, if they are equal to each other, it's going to be right above the midpoint. So if you see that line right there, that dot right here, that's the midpoint. So I put that right above there. That line segment and that line segment are equal to each other. So let's see, PQ, which is this one right here, this white one, and PR, which is this orange one right here. So I want to find, does this one have to be bigger than this one all the time? Well, let's take a look at PR. Let's see what I can do to this. I'm going to try to pivot it right here. Put a dot right there and watch. Yeah, now I can pivot it like this. Now watch. Now if I took R and I scooted it closer to Q, Well, actually, no, I don't want to pivot that. What I want to do is actually I think I want to pivot this one right here, to tell you the truth. Now I know you can't do this on your paper, but this just gives you a good general idea. Hold on, my dog's barking. I gotta go let her in. Alright, I think this is how we're going to do this. What I'm going to do is I'm going to take PR. This program makes a box around it, so I didn't really draw that on there, but you can kind of see. I'm going to take R, and I'm going to take it, I'm going to move it along this bottom line right here. Now look, PR is getting bigger and bigger and bigger, but the only way you could even equal PQ is if it got all the way to actual Q. So it equals right here. The only way it would get bigger is if it goes further along. Then R would not be between Q and S. Remember, R has to be between Q and S. So there's no way it could be out here like this, because R, that would be point R right there. It would have to be between. So there's just no way that this orange one could be bigger than PQ. Look, I could take it all the way down to here. Now remember, PQ and PS are the same length. All right, so the same thing would hold true here. I could take this as far as I want, but it's still going to be smaller than PQ. So what does that mean? It means no matter, obviously it's going to be smaller right here. So what's going to be true? PQ has to be bigger than PR. No matter where R is, R could be real close to here, or R could be real close to here. PR will never be as big as PQ. So PQ will always be greater than PR. So look, that was our first choice. So that really is our answer. Let's just take a look at the other ones just to make sure that we're okay with this. Let me just put this back where it was. Okay. Let's see PQ and QR. Let's see QR right here. Does PQ have to always be bigger than QR? Well, not necessarily, because look. Oops, see daisy. Let's just take. I think it's overlapping that dot. Let's just take R, that point. Tell you what, we'll do this. Let's group them together so we'll just stay as one. Let's take R and just move it somewhere else. Maybe move it like way down here like this. So this would be PR now. So let's take a look. Does PQ still have to be bigger than QR? Well, let me just show you. It depends where this is. Now this is where I'm going to actually turn this and pivot it. Watch, I'm not changing the length of PQ at all. What I'm doing is I'm just swiveling. See how it just swivels like this. So watch that. That's still the length of PQ. If I move R over far enough, PQ is going to be smaller than PR. I'm sorry, QR. Why did I say PR? I meant QR. From here to here. Okay, from Q to R. Hopefully you see that. So this right here is now smaller than QR, and I didn't change the length of this. So does PR have to always be bigger than QR? No, it doesn't. It just depends on where R is. Now if R was, watch, if R was inside of here, from here to about right in here, then yeah, PQ would be bigger. But if I stretch it out further than the length of PQ, then it doesn't have to be bigger. So PQ, so that's not going to work right there. All right. So let's go back. See if I can do this again. And then we'll go back. Oops. Still learning this a little bit. There we go. Let's go back to there. All right. So we know that that's not necessarily true. What about PQ and QS? Well, QS is that whole thing. Does PQ? Well, obviously not, because again, if I did the same thing, if I look at QS is way longer than what PQ is. So that one right there, that was pretty easy to see. So that doesn't have to be true. PR and PS. Where's PR? PR is this orange one, and not PS, but RS. This one right here. Does PR have to be bigger than RS? Well, again, that all depends on where R is located. So if I took R, now right now, does PR look bigger than RS? Yeah, obviously it does. But let's take R to like right here. I don't know, let's take it to about right there. So look at RS here, and look at, actually, let's do it like this, sorry. See, that's a lot smaller now, isn't it? That's a lot smaller than what this is. Now, I know we're just eyeballing it, and I'm not throwing out theorems and all that kind of stuff at you, and there probably are. I just haven't taken the time to sit down and think of the theorems that would apply here. but this is definitely smaller than what RS is, all depending on where R is located, so that's not going to work as well. And then QR and RS. QR and RS. Does QR always have to be bigger than RS? No, obviously not. It just depends where R is again. So if I took R and I moved it right here, oops, sorry about that. Let's grab that, move it here. Okay, QR, does QR have to be bigger than RS? No. I mean, it can be, but it doesn't have to be. It all depends where R is located. So that all depends on where R is. So that doesn't work either. So we were right the first time, and we can just keep it just like that. And anyway, again, there might be some rules, steadfast rules that apply to this, and it could be, I don't know, it could be about, I just don't know. I just can't think of the rules right now, but that just kind of helped me a little bit. So hopefully that helps you.